So thanks so much for joining us for today's Brown Bag webinar. This is Mark Dempsey with the National Convergence Technology Center, welcoming you to today's presentation of an introduction to APIs. If any questions or comments come up along the way during the presentation, please put those in the chat box. Christine and I are watching those. Our presenter is open to discussing them along the way, but we'll also have some time at the end set aside for Q&A also. There will be a very short survey at the very end for everyone, so please stick around for that if you would. Okay. So our presenter today is Mohammed Shoaib. He is associate faculty at Collin College and a full stack developer at Magnit. He has a master's in computer science with an emphasis in algorithms and computer networks. And Mohammed tells me that he lives and breathes web services. So we're very happy to have Mohammed here today. And so I'm going to turn on my screen, share off, and let him get started.
All right. So today we're going to talk about APIs and mainly RESTful APIs. As Mark mentioned, I'm a full stack developer, and I basically work a lot of like web services development. And then he asked me to if I can present or talk about APIs. So let's get into to this. What is an API? So essentially, API is application programming interface, but it's not like a visual interface of what we used to. It's basically where one computer can talk to one service, one website, or to another computer. And essentially, API is just like a broad concept or a general concept. It basically it relies on any other programming language. So you can use any programming language to basically write an API or to basically call an API. So the most common languages that we use for API or JavaScript, Python, PHP, Java, C, and many other languages now. A lot of time you're gonna hear in terms of like the web services architecture is technically divided into many sections. You have front end, you have back end, and you have another database layer. So the front end is where you would have JavaScript, HTML, PHP, or React. And at the back end, you would have a web service. A lot of times they call it web service, they call it a server. And that's where you're gonna write your APIs and or you write a web service. Now the backend would be written into quite often you would see it written in Java or Python. Nowadays you're gonna see a lot of Node.js. So it's like different languages. You can write the backend for a web service or the front end. And in terms of there are different variants to it as well, like you would have front-end JavaScript, then you could have a variant of TypeScript. So you would see all sort of mix and match of that, different kind of strengths and weaknesses of different programming languages. So we're not going to dig deeper into that one. For now, we're just going to continue talking about more like the generalized concept of what an API is and how we can utilize it. So there are many different type of APIs. And when we say type of APIs, it basically means protocols of APIs, because the most famous one nowadays we use are REST APIs or RESTful, the complete name for an API. Now there are other versions to it as well. Some of the in the past, or even some to this day, there is SOAP APIs, and also there's a RPC APIs. And lastly, GRAPHQL APIs. So we a lot of folks who work in enterprise, they probably hear or use only REST APIs. Sometimes you use GRAPHQL API, which is comparatively new, and I'll talk about both of them in a minute. The RPC is very rarely uses basically a function call. Just think of it, maybe you call with some parameters and say, hey, some function or some action needs to be triggered. That's pretty much the RPC API. And then we have SOAP APIs, which used to be a persistent connection with a client and server, kind of so you want to have a consistent and stateful connection. So, and those are the things. So SOAP was pretty famous back in olden days, but not so much anymore. Currently, the most popular one is RESTful APIs. And that's what we primarily focus on today. So what is an API? Think of an API as a waiter on the restaurant. So waiter goes on, what can I get you? And you being basically a customer, you can just order, for example, pizza, and then the waiter relays that message to the kitchen. Now, and then chef goes on and cooks the food and eventually brings back the food that you order. Now, in this case, waiter is an API. It's basically relays the message to the backend, which is technically your chef over here, and then pulls back, brings back the data or the food that you order. So waiter is an API, and that's how simple it is. What an API. Now, essentially, we complicate quite often when we bring a lot of frameworks and tools and whatnot, because every other day there's a new tool. So that's why it kind of feels more complicated than it is. RESTful APIs technically meant to be very simple. And so let's look at an example. And this is there's a website, Skyscanner is one of the website, and it relies on various others websites or services. And here's one example. Skyscanner is one website, and it talks to various other services. And it now that brings up the discussion of microservices, and you probably heard or already read about what are microservices, how they talk quite often. Instead of creating a monolithic service, what we do is we create smaller services dedicated for one task. The idea is that you want the service to be modular. You want them to be dedicated. So if one fails, essentially, your application should not entirely be down. So if there's a small bug or small issue, you should be able to fix it. It's the same concept applies to the to different layers of networking, so whatnot. It's always modular and granular kind of approach. So hence the reason there are various services. In this example, they're like 8 services that we're relying on, and Skyscanner is one let's say one website that we're talking to, and it talks to many services to pull the data. Now, in order to pull the data, obviously it has to talk to those services. Now, how are we going to talk to it? Using an API. So what languages, sorry, this keeps on. So what languages can we program our APIs in? So most famous languages that you have used or heard of, they can be used to write an API. Basically, PHP, C++, JavaScript, Java, Python, Ruby. HTML is technically is the format for front end or web browser. So obviously, it can be used to write write an API, but most of the famous ones can be used to write an API. There's always a pros and cons of using one over the other one, and quite often for a given project, you have to rely on other kind of resources. What you have in a project, what resources you have, so that's how you determine what language you're going to be using it. Again, this is one of the smaller list, but there are many languages that you can you can use to write an API. Now, we talked about that so far, the idea of an API, and now we're gonna dig into RESTful API. Meanwhile, do you have any question on what is an API? How does it work? If there's none, we can continue about what is the RESTful API. So, and we often call it REST APIs or REST. The RESTful stands for representational state transfer. So basically means that a client computer asks another computer for data and take an action. So that's all there is about an API. Now, obviously, one of the benefit is there's no state is being kept. So I initially mentioned SOAP, which always maintains a consistent connection. A state is kept. Over here, it does not keep any state. So most of the connection that you establish for getting a data, you make a request. Your computer makes a request. So basically, when you open a google.com page, you notice like overall like page source pretty minimal, and there are a bunch of .js files that basically end up talking to other services, pull the data for you. So what happens, it makes a request to a backend, a website, a web server somewhere, it pulls the data for you, and done. There's no more state being kept anywhere. The only thing we do is like we often go through, for example, if you're in any university or college server or even your home router, it might keep a cache for a smaller amount of time. So you might able to get the data quicker than basically the actual target server. But there is no state kept for this API call. You make a call, you get something what you needed, and done. So here's one example of like something you can play with. Swappy is a Star Wars API. So basically, on this website, if you go over there, you can connect to their APIs, and you can basically utilize those APIs. You can pull the data for those characters. You can even integrate into your application. So here's one small kind of API call. So you're basically from a JavaScript, you're doing a fetch call, and inside you provide an API/people. So you're pulling the data for people, and I'm gonna explain those different methods for pulling them. So, and over here we are saying once you get a response, convert to a JSON, and then eventually log the response over here in your console.log. So once we get a response, this is kind of a response over here. Notice that it received the result of 10 elements. So we created a 10 element array. And over here, we expanded one, which had a birth year, created, edited, and whatnot, each a parameter or attribute of one item. So there are 10 being returned over here. So this was returned for a Skywalker, and various other characters are being returned as part of this API call. Now that's just for you to just kind of play around, and maybe you can, do you have any question? Okay, going on. So next is JSON. So when we make API call, and we do all the time when we go visit a website, when we and often you're scrolling through, for example, news website or some other pages, or Facebook or Twitter, you notice as you go down, you notice data is being constantly loaded. And that means constantly your request goes from your browser to the backend, pulls the data and loads it. Now, often when I say receive the data, obviously you're getting a data, but it has to be a certain format, and that's where the JSON comes in. So the JSON stands for JavaScript Object Notation. So it's essentially, it's a dictionary or it's a key value pair. That's how simple it is. However, it just became a standard. Before that, it was XML, so you would have basically sort of data represented in XML format. Now JSON became a standard. So like kind of, it's sort of like there was no particular reason how it became a standard. Somebody came up with it, and now everybody started adopting it. And now JSON became a standard. The benefit of the JSON is basically it's a key value pair that you get from making an API call. So before I get to the different actions that we do through API call, and they are kind of universal in terms of different types of API calls that we make. There are 4 different types of actions we do with API call. CRUD is kind of word for it. CRUD, C for create, R for read, U for update, and D for delete. So basically, CRUD operations, whenever we have to write an API call, we always have to think of, okay, different operations I'm going to need. So I need to a way to create resources, read them, update them, and delete them. So that's where different HTTP method comes in. So HTTP is a protocol that's going to help us basically communicate this call to the backend. And what are the methods that basically correspond to those CRUD operations? So get is for read, post is for create, Put and patch also for put and patch are for update, and delete is for again for delete operation. So let's look at the get request method. So we when you need to read something from a website, let's say if you go to a news web page and all you want to do is like go through the different news. That's just simple get request will suffice. You go there and you pull. You go through different kind of links and read the different news. Similarly, if you go to Facebook or Twitter, you go through different pages and all you're doing is retrieving the data from a web server. In this case, you're not creating anything, you're not updating anything, all you're doing is reading. And that's where the get request comes in. And that's is mostly used HTTP method. So as part of CRUD operation, this is the get method would help us resolve the read operation. And one of the examples are like maybe you went to some website and you retrieve the list of users, you retrieve the list of articles, list of blogs, and even for multiple users, you basically read information for one user. So it's all about reading. You can collect a list of items, you can collect one item. Doesn't matter, all you're doing is reading right now. The next is post. When you want to create something, and create something means maybe you want to write a blog. In that case, you have to create something. And in order to create, you are going to use a post request. So in this case, you are going to obviously URL is the way to locate or talk to your web service, and then you're gonna use post as a HTTP method, and inside the body of the request you're gonna specify what I'm creating, what are different parameters gonna be. Maybe for example, in terms of blog, you're gonna write, okay, what is gonna be title, what is gonna be content, what tags and all that stuff you're gonna specify in your request, and you submit it to your service. So that's the post request to create. Now, in this case, for example, you might ended up creating one user. For example, when you create a sign up, that's one of the post requests that you basically enter your user information, submit it. That's one example of post request. Then the next is delete. Delete is basically if you want to delete something. For example, if you want to maybe delete a post, maybe you want to delete a user account or anything like that, you would use a delete request. But obviously, as always, use with a caution because it removes the resources. So over here, you specified technique. And notice it's not unique. It's not a like general URL. You do not say I want to delete users. You want to delete a particular user, but all of these endpoints are dependent upon how the service has been set up. And you have to know exactly what API to call, what parameters it expects. And that's where the Swagger documents come in. The Swagger is basically a place where you will write all the documentation for APIs, where you specify what's the URL, what is going to be API argument, what is expected behavior, what is needed, and all that stuff is going to be specified in Swagger documents. So put and patch. So put is you're going to use if you want to update entire resource. And basically, if the resource exists, it will update it. If it doesn't exist, it's going to create one for you. So think of it, maybe you want to change something about a user. Maybe you want to update a phone number, an email for a given user. That's where the put comes in. And sometime you would want to update a small, some small value or attribute about a resource. Now they are kind of pretty close. Put, patch, and post are very close in terms of their behavior. So post can create a resource, so does the put. But it often depends upon how they have been implemented in their backend. So again, it all depends upon how the web service is written. So how are they going to be? How are they going to behave? So it's all kind of, that's how we can specify them. But at the end of the day, you as a consumer of the API, you have to kind of look through those Swagger documents to know exactly how they are going to work or if it's even allowed. So put is going to update or create entire new resource, and patch would might make an update to it. So patch, if you want to update a piece of resource, versus put might even replace the entire resource, may update it. It's all, again, all depends upon how they have been implemented at the back end. So again, the minuscule difference between put and post is, put and patch is, patch might update a small value for a resource versus put might update entire resource. So here's the entire picture in reference to CRUD operations. The get would do read, post would create, delete would delete resource, put, and patch would update essentially. So that's basically major operations for CRUD and different HTTP methods that we use. Now, in terms of you can write APIs in pretty much any server-side language. So, and it will return the data in a JSON or XML. Most likely it's a JSON. Pretty much that's a standard. Very rarely you will see an example for an XML being returned in a response. So here's one example of JSON. Notice the key value appear in the JSON. So key value example, and then value being value here. Then there's a array example. You got 2 elements, two values in array, and then you got an object which has a key value relationship. If you're coming from Java, just think of it as a hash map. Essentially, key value appears over there as well. All of this data that you receive. Now, you have, so you make a request, server creates a response. When the server creates a response, it sends back to you. Now, obviously on internet, it's gonna basically travel as a stream of bytes. So it's not gonna travel as like a structure as an object. It has to be, the word for it is serialized. It has to be converted to a stream of bytes or into a string. So that's where the data would be serialized. It would be put back on essentially on a network layer. It will travel through the web, eventually will come back to your client or your browser where you would deserialize it and read through the data. So that's the kind of process for it. And then same thing goes the opposite way. You serialize it, you send it to the web service. The web service will deserialize it and read the data that you send it to it.
Okay, there's one quick question. What exactly are Swagger documents, and where can you find those?
So any application that you see on internet, they should have some Swagger documents. It's basically a documentation, which tells you that, hey, these are the methods that are accepted for API. Get, whether it's supposed to get, put, post, or whatnot. Sometimes not all methods are supported. Especially patch is usually not supported by every application, because most of the stuff that you could do as part of patch, you can do with put. So essentially it's a document for your API. So if you're producing or you're writing an API, you're gonna write the Swagger document and share with others. Now, Swagger is basically a standard. How would you write them? And you can use a free version of it to just basically take one key value pair kind of document, put it in there, put through their framework, and it'll show you how they're gonna look like it. Then you can eventually place it somewhere that everybody can access it, right? So now on the front end side, browsers obviously use JavaScript for making interactions with different APIs. So quite often you're gonna see it's gonna use JavaScript, or you're gonna see it's gonna be using maybe React. I personally use a lot of React, but you're gonna see different variants of it. You're gonna see Angular or Ruby on Rails. Like, you basically gonna see all sort of different type of languages to make an API call. But the point is, how are they gonna talk to the backend? They're gonna talk through APIs, and most likely RESTful APIs, because they are the most famous ones. And then in order to do different operations or CRUD operations, they're gonna have all sort of those support for the get, post, delete, and put. So now coming back to what are the common API responses when you request data from a server using post, put, capture, delete. Server returns a response. Now, obviously, response when it returns a response, it returns also a status code. Now, status code you often see, like if you go to a website and you go to developer console, and then you can look at the network layer. Every time it basically you interact with it, it's gonna make another request. You're gonna see the network layer that is making different requests, and then there's a status code coming with it. Now, status code is important. Often you want to look at it to see if you are having problem. Let's say if you're making a request to a web page and it's not loading properly, or you are seeing something, it's not doing anything, then you want to look at the responses, what status code you are getting. If you are getting some sort of like error, that tells you, that might point you to where the problem could be. So if it's a front end error, with a back end error, or different errors can specify or point to like what should you do. So 200 errors, anything that starts with 2 is usually a good response. Like 200 mean all okay. 201 mean that you basically made a post or put request and it was created on the back end. 202 means it was accepted. Means maybe the request you made, it was put on a processing and it'll be done. Put on a processing, meaning it was put on a queue and it'll be done when it turns come in. So quite often you make a request and it tells you maybe it'll be done in 7 to 10 days because it gets put on a queue, and eventually when your turn comes in, it'll send you a response. Then you have 300 responses. 300 responses are often like redirection, where basically the URL has changed or some server has moved to another place and they change the domain and stuff behind the scenes, but you are still able to use the old URL. And that's where the move permanently or move temporarily comes in. And so anything 300 usually mean it's being redirected to somewhere else. Which is again okay. It's not an error. It's just basically saying, hey, since I moved temporarily, I want you to next time store the new URL in your local cache. So next time when you make a request, you would use a new URL. Anything 400, it means the client errors. That means you as a consumer, may have made a bad request. Mark, just wanted to make sure we're not running out of time, but I might need just around 10 minutes or so. I'll be done.
Okay, sure. Those who want to drop off, go ahead. As I mentioned earlier, recording this, we'll go on our YouTube channel when it's all ready, and we will let you know when it's up there. Okay. Okay. So anything in 400 is technically a bad request. That means either maybe your URL is wrong, or maybe you don't have access to it, or maybe some of the parameter is wrong. Maybe your something is missing. So anything like in 400 is technically is the error on your behalf. It's like maybe you're not following the proper format that you were asked to. Maybe required parameter is missing, or maybe your username and password is not right. So all of those kind of problems. Then anything in 500 is a server error. That means it's anything in 500 you get it. That means server kind of got into some kind of exception, and we are well aware of like the programming languages we use sort of error that I mean, you could not do anything about it. Just error happened on the back end, and somebody has to take a look at it and fix it. Now, the last quick slide I have is how do you authenticate it? Well, obviously, when you make an API call and anybody can mimic it, you don't want to allow anybody access to your protected resources. So that's where authentication comes in. So we often use API keys. So basic authentication is provide the username and password. User will be able to log in and be done. However, often you're going to hear JWT or different token, bearer token, and all that. The idea is the user makes a one-time request to the backend, gets a token. Now, every following request would hold that token instead of passing a password every time. Remember, it doesn't contain any state. So in order for us to make a subsequent request, we have to make sure that you still have the right permission to access it, and nobody else is mimicking mimicking you to get your protected resources.
So that's where every subsequent request uses a token. Now, these tokens are also ephemeral. That means they can expire within 5 minutes, 30 minutes. It depends upon how it's set up. So idea is that first time you make a username password request gives you a token, and every subsequent request you pass in a token to it, and that token would basically you'll be able to do all access to your protected resources. Maybe you're talking to your bank. So all sort of kind of personal or protected information would be granted based on your token. Now, here's one example of like a Facebook kind of accessing. You go to this URL and it's going to throw you this error that, hey, you don't have proper token. And obviously you can get a token this website, and then subsequent requests would be allowed. All right. And since I mentioned the GraphQL, and I heavily use GraphQL, that's why I wanted to point out. So basically, this is a newer technology than the REST. The idea is that the REST was the problem with the REST is every time you make a request, you get a fixed response. That response never changes because that's how it's supposed to return. So if you're talking about getting something from a user, it will always give you a same set rigid response. What if you're only interested in just one parameter, one argument of what you are getting from a REST response? In that case, the GraphQL comes in, and GraphQL is invented by Facebook to allow us to make those dynamic requests, and helps us basically change those responses or front end pretty quickly. So here's one example, like the user comes in, and users, we want to get a particular user's information. The next is we want to get all the posts the user made. And the third response is all the followers for this user. So like user/ID would give me one user, so user/ID/post would give me all the posts, and following is the followers. So notice that we made multiple calls for this data. And now notice that we are also getting all sort of information about followers. What if I was interested in only the followers' name and post titles, nothing more than that? I didn't want to read the comments, the content of that post. So that's where GraphQL comes in. You can just search, you can search for a user, and you can get just the name of the followers and the name of the titles of those posts. You can always get more if you want to, but if you're interested in a small amount of information, you would only get that one. Benefit is you can quickly change the behavior of your front end, and you reduce the traffic on the internet. So that's why it becomes more and more becoming more and more famous nowadays. And it has personally helped us like basically adapt to front end changes very quickly. So that's why GraphQL is becoming more and more popular, and a lot of companies are adopting to this this way of calling an APIs. All in all, whenever you talk about API, just think of a waiter as at a restaurant. Notice this website talking to different microservices and how they're talking to one another through using APIs. CRUD operation, we already talked about it. And most of the APIs that you talk to, they're gonna be secure with API keys or APIs tokens, and that's where your credentials come in. Here are different kind of resources that you can take a look at it to learn more about it. And some cheat sheet about APIs. So that's all for me.
All right. Thank you for your time, everybody. If you're watching and recording this webinar, please share, follow, and like us. All right. Thank you again, Mohammed, and thank you everyone for joining us. Have a good rest of your week. All right.